As our world becomes more data-driven, organizations, companies are generating massive amounts of data or getting massive amounts of data every single second. So think of like your finance industries, your e-commerce industries. So the ability to process and analyze this data instantly is crucial for making fast and informed decisions. So today we'll be breaking down exactly what stream processing is, comparing it to our traditional method of data processing known as batch processing, and then going into talking about where stream processing is used exactly in real-world applications. And then we'll be moving on to how to build a data pipeline that's suitable for stream processing, like the different types of data platforms that you'll need. And then at the end, I'll go through a live demo of what that data pipeline would look like and how stream processing looks like in action. So to start, what exactly is stream processing? So stream processing is a method of handling data where we continuously ingest, process, and analyze information as it arrives. So instead of waiting for data to collect over a specific period of time, stored, and then analyzing it, stream processing enables real-time insights and immediate responses. So the traditional method is great for large-scale analytics, but it introduces latency. So your decisions are made based on older data. This works in certain cases and is probably applicable in most of our general use cases, but in stream processing, this is perfectly suitable for cases where you need to process real-time data. And a key concept in stream processing is the data stream. So instead of working with files or buckets of data, we're working with data streams, which are continuous flows of records representing individual events. Some examples can be like clickstream data, where you're tracking user interactions on a website or app in real time, financial transactions, where you're monitoring payments for looking for fraudulent activity, IoT sensor data, where you're analyzing environmental conditions, equipment performance, or smart home devices, or login telemetry data, so you're observing system health and security threats in real time. So now that we've established what stream processing is, let's compare it to batch processing. So if you're already familiar with just general data processing and data pipelines, the concept of batch processing might come to mind. Usually if you're doing any sort of reporting, creating ETL pipelines, or creating machine learning workflows, you're probably using batch processing. So let's compare it so you get a better idea of where stream processing stands. So batch processing is a method of data processing where we're collecting data over a specific period of time and then processing it all at once. This is usually done on a scheduled basis. So this could be hourly, daily, weekly, monthly. And since batch processing handles data in bulk, it's very efficient on large data sets, and it doesn't require continuous monitoring since, unlike stream processing, data isn't coming in consistently. However, it does introduce the concept of latency because you only get the results after an entire batch of data comes in and is processed. So if we think back to stream processing, data is continuous and it comes in real time. Batch processing comes in chunks. And then batch processing, higher latency, stream processing, lower latency. And lastly, batch processing is generally more resource efficient because you can choose when to process that data. So you can pick a particular time where your device, or where more resources opened up so you can use it to process this huge amounts of data. When in stream processing, you don't really get to choose when to stop the pipeline if your data is coming in constantly. So to make this idea more concrete, let's think of a particular example where stream processing is better and when batch processing may be better. So if we think about the finance industry or the banking industry, and we want to monitor for fraudulent activity, when it comes to batch processing, it may not be that efficient or that useful if we're only able to find fraudulent activity after like an hour or a day. You ideally want that notice to come in instantly. So in that case, stream processing would be perfect because you can process your data down to the second or millisecond, and inform your customers whenever something fishy comes up. But if you're looking at your monthly budget or your quarterly report, then there's really not a point to use stream processing to keep up with what your budget looks like every single second. You can do it on like a daily basis or a weekly basis based on whatever you need. So while batch and stream processing seem like completely two different approaches, they actually exist on a spectrum where somewhere in the middle we have micro batch processing. So earlier I said that batch processing, usually the data comes in like hourly or daily. You might have the idea, well, what if we just break down those batches into like really, really small batches, like minutes or seconds? And that's exactly what micro batch processing is. It's an approach that aims to minimize latency while still maintaining some of the efficiencies of batch processing. And since these batches are broken down into really, really small time segments, this makes it almost near real time. But usually these batches aren't going to be any smaller than a second. If you can get your batches down to a second, that's already going to be very efficient. And most frameworks that do support micro batch processing, you probably can't get it down to a second, especially if you're getting in a lot of data. So stream processing, on the other hand, you can get it down to sub-second to like milliseconds. So none of them are like the correct way to process your data. It really depends on exactly what you're trying to achieve. So if you need high throughput, like if you have a lot of data and you don't really need real-time insights, batch processing is perfect. If you want low latency but some delays are okay, then micro batch processing is perfectly fine. And if you just need whatever is the fastest possible, like I need this result right now based off of whatever is the freshest data, then you would want to choose stream processing. Right. Now that we have a solid understanding of how stream processing works, let's talk about exactly where people are using stream processing. So I've broken this down into 4 categories. Streaming analytics, where we're extracting real-time insights from fast-moving data. Event-driven applications, so systems that can react immediately to events as they occur. Real-time data enrichment, where we're adding additional context to our data streams, and feature engineering for machine learning models. So let's start with streaming analytics. So this is usually when you have high velocity data streams and you want to continuously process and analyze that data for instant insights. And this is probably most applicable in the stock trading and algorithmic trading. So financial markets are generating an enormous amount of data every single second. I'm sure a lot of us look at the NASDAQ stock tickers throughout the day, and it's changing every single second. So stream processing enables us to process that data in real time. We can look at the market trends, the order books, and the price movements as they happen, and we can process that data, analyze that data, and it enables traders to make split-second buys or sell decisions. Then another good example would be sports betting or like live event tracking. If you're looking at any type of live sports, things are changing and happening very rapidly. So you want a data processing system that can process those data points and allow you to understand what's happening. Or if you're doing like any sorts of sports betting stuff, those betting odds will be adjusted dynamically to allow your users or your audience to get the latest insights. And another example would be IoT monitoring, so sensors and industrial equipment. If you work in any sort of lab, you probably have those like temperature trackers, just to make sure that whatever environment you're in is at the optimal temperature and humidity. And cybersecurity, again, you're just monitoring network traffic, and you want to do that constantly, and you want whatever's the freshest data so that if anything happens, you'll be notified instantly. Then the next use case that I had up was event-driven applications. So event-driven applications is when you're reacting to the events as they happen. So rather than just looking at whatever statistics is popping up, you're actually doing something or the program that you're building is reacting in response to that. So many modern applications, particularly in microservice architectures, are built around event-driven processing, where different components listen for and respond to real-time data. So some examples could include like fraud detection in banking. Banks can analyze transactions as they occur and flag suspicious activity based on real-time user behavior. So if they know that you're in one state, but for some reason a transaction from a completely different state or country pops up, they can notify you instantly.